Now that we have an understanding of how to make truth tables, we're ready to answer this big question here. How can we tell if two logical statements are equivalent to each other? And the definition here is that the two statements are logically equivalent if their truth tables have the same truth values, that's the same values in the end result column for all possible input values. And if they are equivalent, then we write that as P is equivalent to Q, where equivalent is this kind of like an equal sign, but with 3 lines instead of 2. So let's see how this works in an example here. I want to know if the statements P and Q and the statement Q and P are equivalent to each other. In other words, I'm kind of asking, is this logical AND operator commutative? Right? Remember, the commutative property of multiplication, for example, is the one that says A times B is equal to B times A. In other words, we can flip the order. That's what I'm doing here with a logical AND. So to do that, I'm going to create two truth tables, and this is where this process actually kind of gets a little tedious. You have to create a truth table for each of the two statements, and then we'll compare them. So this is our first statement here, P and Q, and I'm going to do this the same way I've done in the past. I'm going to replace the values in the P column with the values in the P base column over here, and that's going to give me true, true, false, and false. This is really just copying it over. And then I'm going to put the Q values in the Q column. So this is true, false, true, false. Then I'm going to go to my logical AND base table, and I'm going to look up these values. If I look at the row that starts off true and true, the result is true, and the column, the row that starts with true and false, the result is false. The false true row is false, and the false false row is false. So now I'm going to do it again with the table that represents the second statement. So again, I'm going to copy the values, and be careful. This time, for the first column, I need the Q values. And for the second column, the third column, the end column here, I need to copy the P values. And then I'm going to go to my AND table and start looking up the values. The true row evaluates to true. And now I need the false true row. That's the third row of the table. That evaluates to false. Then I need to go to the true false row. That's row number 2, and that's false. And finally, the false false row gives me false. So now what I need to do is I need to look at these two end result columns, and if you compare them, you'll see that they're the same. True, false, 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 and true, false, false, false. So because these end result columns are identical, that tells me that the statements are equivalent. So P and Q is equivalent to Q and P. So in other words, this AND operator is commutative. Now, on your own, you can go and redo this. Try doing it with OR instead. Do P or Q and Q or P, and you should get the same result. You should see that those statements are equivalent as well. So let's look at another example here. Since we looked at commutativity, the other property that you'll hopefully remember from your algebra class is associativity. That's the one that says P plus Q plus R is equal to P plus Q plus R. It's the one that says that you can shift the parentheses around. The order that you add doesn't matter. So I want to take a look at this one and see if this AND operator, again, we'll look at the AND operator and see if this is associative. And you'll notice that our table got a little bigger. with this, to do the associative property, we need three variables, P, Q, and R. So when we go up to three variables, I now have three columns over here on kind of the base side. And now we've gone from 4 possible combinations of true and false up to 8 possible combinations. And again, you can look here and confirm for yourself. I'm going to see if you can find any other combination of 3 T's and F's that isn't on the list here. If you do that, I think you'll see that this is, in fact, all of them. So now I'm going to start off with the same procedure. I'm going to copy the P values into this P column. You'll see this gets a little tedious because there's a fair amount of writing that you need to do even just to get started. Now I'll copy the Q values. True, true, false, false, true, true, false, and false. And then I'll copy the R values, and these just alternate true and false. Okay, now you remember our order of operations for logical statements. We have to do parentheses first, which means my next step is going to be to fill in this column. And to do that, you need to reference that and base table. And if you look up all these pairs of values, true and true is true. And at this point, it helps to kind of start generalizing with the and table. If you look closely at it, you'll see that the only row in the and table that evaluates to true is the true row, the one that starts with 2 trues. Every other row evaluates to false. So that's going to help me to kind of go through here quickly. There's a false here and a false here. All of these have at least one false. Now, here I've come to 2 trues again. So this one is true. And then we're back to all falses. And now, if you remember what we did before, we kind of disregard these 2 columns now. And this column kind of becomes the end result for the entire parentheses. So now I'm going to compare this column with this column, and that's going to give me the values for this final and. And again, I'm going to use the same kind of shortcut. I've got 2 trues here, so that one is true. Then I'm going to just kind of scan down here. I'm looking for other rows that have 2 trues, and I see that there aren't any. So that tells me that every other row here, I can just go ahead and fill in false. All right, so now I have the same procedure to do over here, where the parentheses are on the first 2 statements. I'm going to start by filling in, by just copying over the P values from the base column, then the Q values, false, and finally the R values, just alternating T's and F's. Okay, so now I have to do the ands again, and I'm going to start with the parentheses. So this time that means I have to start over here in the second column, and I'm going to do the same thing. I'm going to look for all the rows that have true on both sides. So that's this one, and that's the only one. So everybody else is going to be false. Then I'm going to kind of start to disregard these columns. I don't need them anymore. And this column is going to kind of be the final result for the parentheses. So this is the column that I'm going to compare to the R column to get the values of this and. And I'm going to do the same thing. I'm looking for situations where I have 2 trues. All right, I have a true here and a true here. So this row is true. And then if I scan down here, that's the only column, the only row that has 2 true values, which means everybody else is going to be false. Okay, so now let's look at our two end result columns. It's this column here and this column here. And if I compare these two columns, you'll see that both of them start with a true, and every other row is false. The end result columns are identical, so I can conclude that the two original statements, excuse me, that's supposed to be an and, not a plus. The two original statements are equivalent, and finally an R. There, this is an and. I don't know how that A slipped in there. So the two statements are equivalent. In other words, this logical and operator does have an associative property. So again, now you should go on your own and kind of duplicate this using a logical or instead of and you should see that those two statements are equivalent as well. All right, so let's look at one more example here. This, at first glance, is the same as the previous one, but there's actually a small but important difference. Now I'm mixing and matching. I have an and for the first operator, but I have an or for the second operator. So now we're kind of asking a more complicated associativity question. Are these three statements still associative even if I don't have the same logical operators? So let's see what happens here. It's going to be the same process. I'm going to copy over the p-values and the q-values and the r-values. And because this is the really tedious part and I like to get it over with, I'm going to go ahead and do the same thing over here. I'm going to copy the p's and the q's and the r's. Okay, now I'm going to go back and start filling in. I'm going to start inside the parentheses, and here I have an or. So I'm going to go to the or table, and I'm going to kind of pull a shortcut here for the ors like I did with the ands. If you look at the or table, every statement is true except for the statement that has the row that has two falses. That row is false. So I'm going to look in here, and I'm going to see I have false and false here, and I have false and false here, and every other row has at least one true. So that's going to evaluate to, those are all going to evaluate to true. So now I can disregard these columns and look just at this one, and I'm going to compare column, what is this, 1, 2, 3, 4. I'm going to compare column 4 here to column 1 with using the AND table. And remember, the AND table is true only when both of the inputs are true. So I'm going to look at every column that has, every row that has two trues. This one does, row 2 does, row 3 does. That, I believe, is going to be the last one. So these are all false. All right, so then I'm going to come over here, and I'm going to start with the AND column. It's the same rule. The rows that are true and true in columns 1 and 3 are going to be true, and everybody else is false. Then I'm going to disregard the inputs here. And I'm going to look just at rows 2 and 5 to get the values for this or. And remember, again, or is true when they're, excuse me, the other way, or is false when both of the inputs are false. So this row is false, and this row is false, and then everybody else is going to be true. True and true. All right, so now let's look at our end result columns. That's this one here, and I'm going to compare that to this one here. And let's see what happens. We have true, 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 false. Uh-oh. Look, what row is this? 1, 2, 3, 4, 5. Look at what's happening on row 5. This table is false, but this table is true. In fact, rows 6 and 7 also don't match. So because every row doesn't match up, these two statements are in fact not equivalent. So we don't have a general associative property. We saw in the previous slide, if the operators are both and hopefully you proved for yourself if the operators are both or, then the statements are equivalent. There's an associativity. But if the operators are different, then the associative rule does not apply. You can't just move the parentheses around. And again, if you're looking for one to do, a similar one to do on your own, I mean, just flip these. Do it or and then and, or and then and. If you look at those expressions with the logical operators switched, you should see, once again, that associativity doesn't apply there either. So in the next presentation, we're going to continue this. We're going to look at some more equivalence examples, and we're going to look at some more specific ones that are very well known, ones that you can use in a lot of cases to simplify more complex expressions.